I show 7 o'clock Pacific. We'll give it a few minutes for folks to show up, then we'll get started. Nexus Artemis 09. Awesome. How are you, Izzy? Izzy, you emailed me. Thank you for showing up. This is awesome. Appreciate it. Try to make this worth your while. Welcome, Jason. Glad you're here. Where are you guys from? Throw it in chat. Where do you live? Oh, cool. Vancouver, BC, or just across the river from me in Vancouver, Washington? Probably Vancouver, BC, a little more likely. Yeah, cool. Thanks. Northeast Tennessee, that is beautiful country. I've been there. Awesome. Okay, good. Well, you guys were on time, so we're going to get started for you. And this video will always be available on my YouTube channel afterwards. Anyway, so first things first, Twitch is odd in that I can only have chat conversations with people. So hi, Brendan. I'm going to be watching chat as best I can while I talk. Future classes that I do will be set up so that you can actually, for the people that join the actual classes I'm doing, they'll be in a Zoom call and I can talk to them. But for now, there'll be a little back and forth where if I ask a question, you'll see me looking over and looking at chat, and then we'll have our conversations that way. So here's what I'd like to get done tonight. By the way, just by way of background, again, my name is Eric Gross. I have been coding since I was 11, and I'm old, so that's a long time. I co-founded a software developer boot camp. I teach during the day for one of the biggest technology training companies. I've been a nerd for a long time, and I really, really like helping people with technology and become developers. Been doing a lot of work with JavaScript for a lot of years, and part of what I had to do is work with people that are brand new to the industry on JavaScript. And so I hope I can help with just some fundamentals and some orientation to help you think like an engineer, think like a developer, and be able to both analyze existing JavaScript code you bump into and create your own code a little more easily. But we're not going to do that by just jumping right into JavaScript. I want to cover just a few points of just some fundamentals about computers and about any computer program, no matter what the language is. And then we'll look at JavaScript examples. And when we get to the point where I'm looking for, going to go over JavaScript examples, I'm really going to look to the chat for people to give me examples of stuff they'd like me to go over. But for now, let's just look at a couple fundamentals about computers. Now, these next few things I'm going to show you should seem rock dead simple. But there's a method to my madness. There's a reason why I want to go over these fundamental things, because we come back to them over and over again when we're building programs. I know I do, and I've been doing it for a long time. So let's look at just some basics. And by the way, for those of you who have the bottom left-hand portion of your monitor visible, you'll see I've got a little utility put in that shows what keystroke I'm using. Like right now, you see the down arrow, that sort of thing. So if you're ever in doubt about what I typed, you'll be able to look at the screen and see it. All right, so basics of computers. So what is coding anyway? Well, it's entering instructions into a computer to make them perform specified actions. But if any of you've ever done any coding, you know that that's a pretty lame sentence. Like that applies to like using a computer program. When you're using Excel or a word processor or whatever, well, you're entering instructions into the computer to make them perform specified actions. The difference is we want to be software developers. When we write we put instructions in the computer, those instructions will be a program that someone else can use. So when I say entering instructions into a computer, this means laying out the instructions that will give someone else some feature, some behavior in a program they get to use. What's a computer? A specialized type of machine. And this is important, the purpose of a computer. Again, I know it sounds super simple, but it's important to think about it, because it comes back when we're doing web development. The purpose of the computer is to take in data, work with that data in some way. They call that processing data, and then pass that data on, either to another computer or to a physical device, that sort of thing. So computers take in data, work with the data, and pass it on. And that rock dead simple explanation can be quite useful. Let's add a little more complexity. Computers are only machines, they're not people. They were created by people. They can only act if a person tells them to. And even then, they can only perform the actions that a person thought of ahead of time and built into them. That's pretty important to know. Now, again, I'm suspecting that most people on this stream have done some coding, and they know that. They're the ones that are coming up with some of the instructions on what to do. But every once in a while, you bump into people that think that computers can think. And they can't. They can only do what they're told to ahead of time. All right, so let's talk about programs and programming. Programs are a series of written instructions. They're entered into a computer, and they cause the computer to perform a specific task or tasks. Usually that task or tasks involves bringing in data, processing it in some way, and sending it on. Often sending it onto a display so that people can view an interface. Now we're going to get a little closer to JavaScript. When we talk about programming languages, there's just organized systems of words and phrases and symbols that let you create programs. There's lots of programming languages, thousands of them. The one we're going to concentrate on is JavaScript. Let's get a little more detailed, though. This is something I don't see presented that often. And I come back to this all the time, even as a senior developer, a senior engineer. Any computer program, it doesn't matter what the language is that you're writing, it really only makes use of 5 different elements. And we'll talk about them briefly, and then we're going to show them to you in JavaScript and get your thoughts on them in chat, all right? There's an entrance point. That is the very first instruction in your program that is to be performed. You've got to be able to tell the computer, and more precisely, the part of it in it, the part in the computer that's a brain, it's called a CPU. You've got to be able to tell that CPU, where do I start with this program? What's the first instruction to do? And then the program just goes in order after that, but it has to know where to start. And that actually comes in super useful. I'll show you how later on. A computer program has to make use of variables. This is data that has a name. They give a name to the data, like age or color or car model or whatever. And more importantly, that data has a value that can change. Every computer program has to make use of control and branching statements. They make decisions. Now, they only make the decisions we think of ahead of time and program into them. But these control and branching instructions, they help us make decisions. More precisely, these instructions vary something that's called the path of execution. A program can be thought of as a just linear series of steps. Do one thing, then do the next, then do the next, then do the next. That's called the path of execution. What path do I going to go down in executing all these instructions? And when I say what path do I go down, I mean the computer. Well, these control and branching instructions, they're instructions that can say, when you get to a certain point, there's 2 or more directions you could go, 2 or more paths of execution. Which one do I take? Super valuable in programs. And again, this is rock dead simple stuff, but it comes in very helpful when you're trying to learn a new computer language. Here's one of the most important things: sub-programs. These are repeatable chunks of instructions. You can call upon them as needed. Instead of typing the same thing over and over again, why not take this thing you're going to use over and over again, give it a special name, and set it off to the side? And then when you're going down this quote unquote path of execution, when you need to do that thing in that chunk of instructions, just call on it. And when it's done, you'll come back to the path of execution. And that going away and then coming back is super important. We're going to look at that in JavaScript. And by the way, in JavaScript, these subprograms, we call them functions. Finally, and this is something you don't think about, but it's kind of important, every computer program needs an exit point. This tells the computer that I'm done running that program. You can release any resources that you had reserved for my program, release them, and make them available to other programs on the computer. So a pretty important point. So those are 5 elements any computer program has. And if you're learning a new computer language, this is generally where I recommend starting on just understanding that language. How in that language do I designate what the entrance point is? How do I declare and work with variables? How do I determine these control and branching instructions in this particular language? How does this language implement subprograms? And there's lots of different variations on that for lots of different languages. And finally, is there anything special I need to do when that doesn't, this program's done, it's closed out, it's exited? If you just study any new language with these 5 things in mind, you'll rapidly sort out what that language is all about. Now, again, we're going to talk about JavaScript with this one. So we're almost to the point where we're going to write some nerdy code and we're going to look at some stuff. But this next thing I want to show you, some of you may already know about, some of you might not. it's pretty important to understand that when you write a program, you're writing it in a language that you can kind of read. It's very much like English. It's not what a computer can operate off of, though. A computer can actually only operate off of one language. No matter what the computer is, worldwide, they all operate off a specific language called machine language. Now, what that language looks like can vary depending upon who manufactured the actual computer, or more precisely, who manufactured the CPU, the central processing unit that's inside that computer. Now, I don't want to go down a big old rabbit hole here. You can get really, really nerdy about it. But the fact is that when you buy a CPU, inside it is a set of about 20 or 30 instructions that are the only thing that CPU can actually do. Things like reading data, doing math, working with text, that kind of thing. Those are the only things that that computer can actually do. And when you write your big complex programs, we have to break down what you wrote into a series of instructions that's made up only of those things that that specific CPU can do. Now, normally when you're programming, you don't need to think about this, but you do need to know that that's what's happening under the hood. We write in some language a command that says display the word hello. That language, let's say JavaScript, gets translated down to machine language. That's the language the computer can actually understand and operate off of. And it's made up of patterns of ones and zeros. That machine language instruction or instructions are passed into the computer. And when I say computer here on the screen, I specifically mean the central processing unit. And then the computer can actually do some work. And the work it does involves taking in data, working with it, and then passing it on. In this case, passing it on to a display device called your screen. And there it is on the screen, right? So again, I know what I've gone over for the last 15, 20 minutes is super basic, but there is a reason for it. If the fundamentals are in, if you understand the simplicity of what a computer is doing, analyzing any new computer programming language you're learning can be pretty easy. All right, so let me look at chat real quick now that I've yammered on a bit and get some water out of my, of course, Gryffindor mug. For those of you who are Hufflepuff or even Slytherin, I apologize. You're still allowed to stay on the call or on the meeting. Okay, dude. Broken Sword X. Really glad you're here, man. Really glad you're here. Okay, so let's look at a couple other things. Now we've gone past basics, okay? So we understand that, no matter what, when you're writing whatever language you are, we're going to translate that down to machine language. That machine language gets passed into the central processing unit. Then finally some work gets done and, we've made a program. But now we're talking about the realm of web programming. And so I'm actually going to ask a question and I'm going to look to chat. Take your time on the answers to this. We've got some time here today, folks. Can anyone take a stab in the chat? It's just explaining in simple terms what they see the difference between the web and their internet being. What's the difference between the web and the internet? Any and all answers are totally fine, including none if nobody wants to put anything on there. Okay, then here's my next question. Is there anybody here who has thought that they're basically the same thing? Yes or no? Throw that in chat if anybody thinks like, well, they're kind of basically the same thing. It's totally fine. I'm just curious. Oh, I like that. Epic 122 says internet is what we're connected to. The web is what it works on. Broken Sword, internet to me is interconnection of all things. The web to me is browser-based files located on servers across the world, I guess. That's great. That's great, actually. Good. All right, so let's look at a simple explanation here. Now, before I go into this, I want to caution you. Once it's really clear in your mind what the difference is here, you're going to see in life that people are just going to actually use the two words web and internet interchangeably. You're now going to know the difference in a pretty simple, concrete way. Don't make them wrong for it. I use those terms back and forth interchangeably all the time, and I know very clearly that they're different. But as an engineer, you need to know the difference. So The internet is hardware. In fact, it's a network of computers that are around the world, literally billions of computers, all connected via wire or wireless signal. Doesn't matter how they're connected, they're connected. But there's a second thing in the internet, and that is a set of agreements, we call them protocols, that explain how to exchange information between the computers. So the internet is just hardware, connected computers, along with a set of agreements about exchanging information between those computers. That's what the internet technically is. Now, we use the word internet all the time to mean this second thing, the World Wide Web. And as Broken Sword X said in the chat really well, the web is just a collection of documents, but they're special documents. They are linked one to another. So the web is a collection of linked electronic documents, and we call them web pages. Those are two completely different things. One, the internet is just hardware and a description of how to exchange information. The other one is a bunch of actual documents that somehow are linked. So this is the world you're going to live in as a web developer. And so you do need to know that they are, in fact, two different things. All right. So now we're going to get to the point where we're looking at JavaScript. But I want to stress something. We said earlier, I'll go back a little bit, JavaScript is not something that a computer can actually run. If you feed JavaScript commands into a central processing unit, nothing will happen. Those JavaScript commands need to be converted into this machine language. Then that takes a special program. So when we talk about using a specific language, we need to look at the concept of what's called, and this is going to sound kind of nerdy, what's called an execution environment. Now, that doesn't mean France in the 1700s. That was a history joke. I'm sorry. What do I mean by an execution environment? Well, we need an environment inside the computer where the commands that you write in one language can actually be executed or performed. So we can already see that what we're going to need at least is a program present that you can feed in your JavaScript to, and it will spit out machine language. At the very least, we're going to need that. We call that program, by the way, a JavaScript engine. It's like an engine. It's a constantly running little program. And you can feed JavaScript in one end of it, and out the other end, it spits machine language. We, all of us, guaranteed, have one of these on our computers right now. Can anyone tell me in the chat where they think the JavaScript engine is, this little program that can convert your JavaScript down into machine language? Where is it in or on your computer right now? And by the way, Nexus Artemis 09, the set of protocols, yes, it is things like HTTP. Good, couple correct answers. It's in the browser. So browsers on the surface would seem to be a pretty simple thing. Their job is to send out a call across the internet from one computer, yours, to another computer, a web server, requesting a specific file, the web page file, and it comes back. And that's all true. That file that comes back is HTML, hypertext markup language file, right? But another type of file can be sent to your browser, JavaScript code. And it's your browser that says, oh, I know what this is. It's JavaScript. Well, let me go and start reading through it, converting it to machine language, and then running it. So as web developers, we get our users' computers to do our work for us. We ship the computer program to the user, to their browser, and their browser actually runs the code for us. It's kind of cool. Now, why am I getting into all that? Okay. JavaScript runs the V8 engine. It's kind of the right thing. The V8 engine is one example of a JavaScript engine. So it wouldn't be that really you say that JavaScript runs that engine. It's more that that engine is running in a lot of browsers. It's called the V8 engine. That's a JavaScript engine. That engine, that little teeny computer program, is constantly running while your browser's on. And you feed in your JavaScript code to it, and it spits out machine language. Cool. And by the way, they will be posted to watch later. You can always go to my YouTube channel, right? And they will be on there. So the links to my YouTube channel are right there on Twitch, and this will be posted when we're done. So totally fine if you have to fall off, no problem at all. So now let's get into some actual JavaScript, but just bear in mind two things. One of them is this process you see on the screen of converting your JavaScript down into machine language will have to happen. Two, keep in mind these 5 elements. We'll come back to these and we'll demonstrate them. All right, so I want to kind of open up the floor a little bit here. I'm going to watch chat. I already know a couple of things when I was, when I posted it out on Twitter that people would like to see explained a bit more, or some examples, have questions answered. I know that functions are one of them, right? But I'm going to ask right now, is there anybody that, put it in chat, specific things they've bumped into in JavaScript that like kick their butt, they want to like explore a little bit, that kind of thing? All right, so I'll watch the chat. If you think of something, throw it in there. But let's just go back to let's look at these things right here, the 5 elements of being a computer program, and let's explore that a little bit. Entrance point, variables, control and branching. The return variable. Okay, good. So let's look at this for a second. I'm going to sketch something out for you. So let me check on something here. Give me just a moment. I'm going to stop sharing for just a second on the screen. Okay, good. Hi. And I'm going to pull in my iPad. I should have gotten this ahead of time. I apologize. I didn't. So I'm going to pull in my iPad and be able to diagram something for you. Now, one thing about this is that I won't be able to look at chat for a minute while I'm sketching. So just bear with me on it. All right. So I talked about this thing called a path of execution. And you can think of any program this way. And as simple as it sounds, a program literally starts at the top and goes to the bottom. Now, there are, it's a bit of an oversimplification, but honestly, not much. This is an instruction, another instruction, another instruction, another instruction, and so on and so forth. And the program will literally go from one to the next, to the next, to the next. It's a pretty simple concept. This is why people made computers in the first place 70 or 80 years ago. So this is this path of execution. Now, right on the screen here are a couple of the things we described as the 5 basic elements. An entrance point, the first instruction to be performed, and an exit point, the last one. But let's look at this idea of a sub program. It's just a series of instructions that you want to have performed, and you want to have them happen over and over again. Typically, they're given a name, not always. We're going to call this SB1, subprogram, SB1. Really, Eric? Subprogram 1, SP1. Okay. That's this little collection of statements. And we're going to code one of these out in JavaScript in just a second. Now, I said earlier that it's a repeatable chunk of code that you can call on as needed. And the way it works is that you'd be going along, you're on one instruction, you get to the next, and all of a sudden, The next thing you need to have happen happens to be what's in this repeatable chunk of code. The computer will literally stop running this path of execution, the main path of execution. It stops, it holds. It says, all right, I no longer have control. Me, the main program, this is your main program right here. I'm no longer in control of the path of execution. I'm going to kick that control over to this subprogram. This subprogram behaves like any other program. It does one instruction right after the other, after the other, after the other. When it's done, control comes back to the main program and it picks up where it's left off. In JavaScript, we call these subprograms functions. Now, one of the things in the chat was, what about this return variable kind of thing? Okay, so let's think about the different possibilities here when I'm going to write in a different color here. Give me just a moment. You, as the program designer, decided right at this point, I need to call on this program over here. Whatever its instructions are, I need them. I need them to be done. Well, there's a couple of options there, depending upon what exact needs you have. You can say, listen, I'm going to call on this little chunk of code to be performed. And when it's done, I need it to send back something. I need it to return something. Why? Because the main program needs it. That's not always true. Sometimes the main program just needs this work to happen and just to know that it's done. Just tell me that it's done. That's all I care about. But other times, it needs to send something back. Regardless of whether it needs something back or not, when this subprogram is done, the main path of execution is notified and it says, oh, good, thank you. And it goes on to the next instruction it had, the next instruction, so on and so forth, until and when and if we need that subprogram again. We say, oh, wait, I need that subprogram. And then execution goes over here. It pauses on the main path of execution. We're just waiting and waiting and waiting until this is done over here. So this return variable, you don't necessarily need one. But when you do, depending upon the language, you just have the final instruction be return, and then you return something. That something goes back to the main program, probably to be used by it, or we wouldn't have asked for it in the first place. So we'll code out an example of that. Before we switch back over to the code, I want to point out one other thing. Sometimes when you are on the main path of execution and you get to this spot where you need a subprogram and you call on that subprogram to be performed, sometimes you know that subprogram has needs. It has specific things, and I'll write this in a different letter or a different color. It might need two different pieces of data. These green dots are my two pieces of data. And the subprogram needs those in order to actually do its work. It isn't always true, but sometimes something that the main program over here is keeping track of, it needs to send into this subprogram. The subprogram needs that in order to do its work. That's not always true, but sometimes it is. When that's needed, these things that are passed in are typically called parameters. In some languages, they have different names, but it's the same concept. Who cares what they're calling it? We just know that something is needed by the subprogram. So now we've got some diagram in front of you and some terminology. I'll review it really quick and we'll jump back to coding. The path of execution starts at the top, continues one step at a time until it reaches the bottom, the final step. At any point along the way, if you define some sort of subprogram, the main path of execution can kick over control to that subprogram, and it'll wait until it's done. And then the main path of execution continues on the way it works. You can, if you need to, when you call on this subprogram to be executed, you can give it pieces of data. Typically, those are called parameters. And when this subprogram is done, you can, if you need to, have something it made be sent back to the main path of execution. This thing I'm showing you on this screen is true of every computer programming language. There's lots of nuance about how they implement it, but the concepts remain the same. All right. Let me go ahead and stop sharing. Switch back over to Twitch. All right, good. Yeah, okay, good. This keyword, we'll get to that in a moment as well. So let's code out some of that nerdiness that I just put in there, okay? I have in my Visual Studio Code a really simple web page. And I have some script work in it. And we're going to do our work here for a moment. And then I'm going to pull it out into a separate file because it makes it a lot easier. But I just want to point something out, that this is an HTML document. You've all made them, I'm sure, if you're on this call, right? And it's just important to realize that outside of this highlighted part, everything else in this document just is content or instructions on how to format that content. Everything inside here, though, is an actual computer program. And so when you start reading through these things, keep in mind all 5 elements I talked about earlier. And that would be, there's an entrance point. What's the first instruction? There's an exit point. What's the last instruction? When do we know we're done running this code? There's variables. There's control and branching statements. And there's subprograms. All 5 of those things apply, right? Oh, thank you so much. You rock, chat. This is what I was looking at. So here's a simple HTML page. Everything outside of this section here is all just content, or it's instructions about how to format that content, what its appearance and style is. Inside here, though, this is code. So you don't read it the same way. The fact is, and this is where we get back to some of the nerdy stuff I was talking about at the beginning. Remember how it said, like, the purpose of a computer is to take in data, process that data in some way, and then send that data on? Well, that's what this HTML stuff is. It's data to be sent into a computer program, in this case, a browser, processed in some way, and then sent on to another computer or a device. In this case, they process it and they send the processed data to a screen. And that's how you see a visual, a UI, a display, right? Now, go back to scripting though. Everything inside here, this is actual code. So we're going to write JavaScript in here just for a moment. And then to make it easier to follow everything, we'll put our JavaScript in a separate page. So let's take a look at some basics here and just start with, well, let's make use of a variable. Let's make a variable and we're just going to kind of call it foo. That's our first instruction. And it's going to be equal to the word bar. Fine, whatever. Simple. We know that's our first instruction. And we know that we can now do another instruction. I know this is really simple. And we're going to do an alert with foo. Now, again, rock dead simple, but we're going to build up to building a function here. And the fact is, we are calling a function. We're calling a function called alert. It's built into JavaScript. We're not making our own, but we're calling a function called alert. And we are, in fact, passing in a parameter. We don't have to declare anything in return because we're not making alert. So let's just run this. I think I have an extension in. If I do Alt-B, it should run this. Yeah, it ran it in a different page. Let me pull this onto our screen so we can see it a little more easily. And I'll just refresh it. So here's the first point. And this just speaks to trying to debug code and follow along with what's happening when you're trying to also learn the language for the first time and you're learning 3 different things at once and you're doing this in your spare time. It can get really confusing, but fall back on the fundamentals. The fact that this alert function is even able to display the word bar tells you something. When we go back to the code, it tells you that these things are executed in order. What happens if I take this instruction and put it first. Now, I'm reading this, and as a human being, I can read this and go, alert foo. Oh, it's going to do this foo, and it's going to print its value. What's the value? Well, I'll read farther down because I'm a human being. I'll go, well, the value of this foo variable is bar. Oh, so this should put foo on the screen. All right, well, let's go ahead and see if that works. And surprise, surprise, it doesn't work. Now, that's a stupid, simple example. But it just points out when you're reading through your code, read it like you're a computer. Read it like you are bound by the simple rule of you can only do one thing at a time, and you do the instructions in the order they are presented to you. You can't read past it to figure out what's going on. That's something we humans can do really easily, but computers can't. All right, now let's start building some actual functions here. First thing I want to do is, instead of typing here in the middle of my page, I want to actually have a separate JavaScript page. I'm going to put all my code here in something I'm going to call main.js. Doesn't matter what the name of it is, as long as I point to it. So here in my index, I'm going to point to this. I'm just curious, in the chat, someone put in the chat what they think the right syntax is to point to this file over here called main.js so that I can run the JavaScript I'm going to put in there. I know there's a little teeny bit of lag between what I say and when it goes live on Twitch. It's only about 2 or 3 seconds as far as I know. Import, I love that. Hallway Ghoul, that's a great username, right? Says import, sort of. We're on the exact, we're kind of on the right track, okay? More precisely though, source equals main.js, yeah. The import thing, we'll talk about in a little bit. Okay, put that down as one of the things we need to go over. But for right now, when you're looking at just a simple web page, if that web page, as the browser is processing the web page, if the browser needs to look somewhere for JavaScript code, this is how you do it. You do a source tag. Let's see if I can actually spell here. You do a script, and you do the source for it. This is an attribute of your tag. And here, you're actually going to point to the place where your JavaScript is going to be. That's how you do it right there, okay? Now, I broke a link here, and I want to know how and why. There it is. Okay, good. So now we can actually point to this. And here's the other thing. Our web pages, these HTML pages, they are read in essentially from the top to the bottom. They are not instructions. This is not computer code right here. All this stuff is not computer code, but the program that processes HTML reads through these files in much the same way, i.e., from top to bottom, basically. So it's going to read all the way through, and it's going to get to this section, line 18, and it says, oh, I need to run a script before I proceed. Where do I find the actual script? Where do I find the computer code? It's going to be in main.js. So now we can start to do stuff in here. So let's reproduce the same thing we had before, just so we verify that it works. We're going to take var foo equals bar, right? And put it in here. And then we're going to do an alert where we alert foo. And let's just make sure that runs. I just add a little bit of complexity. I'm not running my script directly from my web page. I'm now pointing somewhere else. So I've been doing this for many years. I'm never going to trust that I did this right without testing it. I'm just going to put something inside my main.js that'll do stupid, rock dead simple code, and I'm going to run it and see if it works. So I'm going to do my little extension here in Visual Studio Code. Lets me do Alt-B and just run it. I broke something. Let's see what it is. There it is. Okay, good. Good. So something isn't working. Let's find out what it is. Now, here's the thing. Because your browser has one of these execution environments, we can actually look inside the live execution environment and see what's going on. That's what these developer tools are all about. So I can look in here and go, okay, I have sources that the browser is using to do its work. I have an index page and I have a style.css page. Well, I can see right away that I did not get a JavaScript page here. So something's wrong. Let's see if I do empty cache and hard reload. No, it still didn't appear. So I have screwed up something and this file is not showing up to the browser. Let's see what I did wrong. All right, so index main style, Eric demo. I do have autosave on, correct? Yeah, I have autosave on. Should be appearing. I'm pointing to main.js. Let's do control click follow the link. Yeah, it looks like it's proper. There's a suggestion. Just do main.js. That's probably right. Let's go back. Nope, didn't show up. All right. You can self-close the script right here, the script tag. That's totally valid. Let's, if we did like that, that's also valid. There's no content to it. It just has a source. So what do I do when I come into this? And by the way, this is not uncommon. You bump into like, I think I remember the syntax on this. So just look it up. One of the beautiful things about being a developer and engineer is that you don't ever have to memorize a lot of things if you understand the fundamental principles behind it. I've done something wrong in my syntax. Syntax delete JS file from HTML. Here's an example, and I certainly think I have it right, but we'll grab it and we'll just look. This is how they say we're supposed to do it. Well, source equals, let's go ahead and take what I know it to be, path to JavaScript. And it's main.js. We'll erase mine. Should be working. And let's see if my Alt B works. That's Control B. That's not what I wanted. Alt B. All right, it did work. It's on the other page. Let me pull it over. Okay, good. So I've got it working. Now, I'm really glad actually that got messed up. And here's why. One of the things that can happen when you're writing a program is you kind of have in your head maybe a partially fleshed out idea or even more fully fleshed out, and you kind of want to just write all the code for it. And you can end up writing big chunks of complexity. And only then do you try to run it. And it breaks. You now have 5 or 6 or 7 potential places that are responsible for it breaking. When I'm building a program, I try to build it in tiny little chunks at a time. Now, I don't mean the organization of the code. I mean, make a little teeny change and then make sure it still runs and I'm still on track and it's still doing what I expect it to. Constant little bits. Now, what I changed there in this program doesn't change the actual behavior in the program at all. I'm still getting the exact same behavior. We are creating a variable called foo with the value of bar, and then we're alerting. We're doing an alert box with that. It's not complex. I didn't change the behavior, but I changed substantially the organizational structure of my program. The actual computer program I'm running, which is all of 2 lines, I'm so proud. I'm running it in a different manner. And I better test that I've got that wired up before I go into some complexity. So it's good that that got messed up. Now, let's get into actual functions here, okay? And by the way, thank you for the suggestions in the chat. That was awesome. All right, so we've talked about these 5 things, right? You have an entrance point, you have variables, you have control and branching statements. Branching is not a word. You have subprograms, and you have an exit. So let's first of all just make a main path of execution. We're going to make one, a series of steps. They'll just go in order. And I'm going to make a variable. This is called first name. And I'm going to learn how to type. And I actually am going to just do something I can watch happen. I'm going to do a console log of it. All right. And then I'm going to do a var of last name. Same thing, a console.log. I'm making a simple program here because I'm just trying to illustrate something when we start bringing in functions, okay? And I'm going to, console log last name. Great. Now, go a little bit past that. We're going to leave some space. We're going to put in a subprogram. And now I'm going to do another console.log. This is the last instruction, and it's going to be first name plus a space plus last name. All right. You can kind of think of this as make a display-friendly name. That's a display-friendly name, okay? So I've decided I don't want to go through this first name plus last name every single time. That's complex and it's a pain to type. I don't want to do it. So I want a little teeny program that I can call upon over and over again, that if I give it a first name and I give it a last name, it'll spit back to me a string with those things combined and a space in between. By the way, this seems super simple, like Eric came up with a dumb example. You write routines like this often in user interface programming. That'll actually just create the display-friendly name for you, so you don't have to do it, okay? So let's look at this subprogram, and we're going to build this function, and we're going to build it from the point of view of these 5 elements and the fact that a computer program has to do everything in order, and the idea of a main path of execution. So I want a subprogram. Now, where do I put this program? I haven't called on it yet. I'm just going to set up a set of instructions that if I want to, I could call on. Where would I want to put that, right? Well, you can put it in a lot of different places. That's a matter of code organization. I'm just going to look at the simplicity of if I'm going to call on it at some point, I need to at least put the definition for this subprogram before I call on it. For example, let's pretend we know what this is going to look like once I have the program. It will be something like console.log and it'll be calling make display name, and it'll be passing in first name and last name. That's probably what it'll look like. Well, I actually kind of like that name. That's a fine name for a function, right? But here's the point. What if I start making that function down here? That was really, really bad typo. What if I start making this function called make display name down here? And I even pass in a first name and a last name. And I start actually making the function. my computer program is going to break. Let's prove it. Let's actually make the function. What do we want this thing to do? Well, taking in two strings, a first name and a last name, I want it to, and I'm going to write this the long way and then we'll shorten it up. I want it to say, all right, well, I'm going to have a display name. And I'm going to make it equal to F name, not first name, F name plus, and here's the space, plus L name. And then I'm going to return, really, this display name. Now, yes, there's much more friendly ways to write that. I'm not analyzing the function. It's more reinforcing the fundamentals of how a computer program gets processed by the computer. This should not work. Let's try it. So I'm going to do an Alt B, or actually, if I go back to my, do I still have my alert? Good. I don't want any alerts. All right. So where am I going to see my output? Well, it says console.log. Where is the console? Someone put it in chat. Where do I find this console? Now I can take a drink of water. DevTools, exactly. And why? Why is it there? Well, because it's inside the browser that my JavaScript is actually being executed. Now, remember, we're going from a text file. This main.js, it's a text file in the file system on my computer. But it can't run, it can't actually be performed until I give this text file called main.js, until I give it to a browser, because the browser is responsible for maintaining an execution environment where we can actually run JavaScript code. So every time I go back to the browser and I click refresh, what the browser is doing is reaching down into the file system, grabbing all three of these files and doing its job. It's going into index.html, starting to read through and create a rendering for the screen. It gets right to this line right here and says, oh, I need to run a script. Well, where is it? Oh, it's right here. And then it goes in and instantly starts running the code. It makes a variable. It logs it. It makes another variable. It logs it. And then it does whatever's going to happen here, and it's probably going to break. But all of that work is being done inside your browser. So let's go ahead and go back. We'll hit refresh. We'll see what happens. Maybe I should inspect and look at the actual console. And I got some Eric Gross, Erica. Now, this is pretty interesting. This does work. Can you tell me why they think this works? Here we are, and we're calling this function. By all rights, it shouldn't work, because we're calling on something that hasn't even been explained yet, hasn't been defined yet. Anybody got any ideas about why it might work? Go and put them in chat. Ooh, I like that. Both of these things are pretty spot on. Compiled by the JavaScript engine and then run. It's not run as it's rendered or as it's written. Yeah, see, here's the thing. This is going to get a little nerdy, but JavaScript is, in terms of different types of languages, it's what's called an interpreted language rather than compiled. It was designed that way. In other words, one instruction at a time gets converted to machine language and then executed. Then the next instruction gets converted and then executed. And that's why it was designed years ago, but it's become a much friendlier language. And they've built systems around it that make it so that you don't necessarily have to structure your JavaScript that way. Now, here's where we get into trouble, is there are certain environments where you can run JavaScript that are super picky about it. Not every browser works the same, for example. Every browser, think about this, every browser has to provide some functionality for letting you run JavaScript code, and they all do it in different ways. Many of them solve it by getting this thing called the V8 engine that was referred to earlier in chat, and just getting that from Google because Google created it and using it in their browser. Some of them make their own JavaScript engine, and they all behave in slightly different ways. The one in Google, which is this V8 engine, is very developer friendly, and it will let you do something like I've done right on here. However, not all languages will be so friendly. Not all environments to run languages will be so friendly. So my recommendation to you is to keep the fundamentals in mind and make it so that if you're going to declare a function, that you declare it before you call on it, because many languages will yell at you if you don't do that. All right, now, that's all well and good. The question was about functions and return variables and all that kind of stuff. Let's go ahead and talk about that and what it means. Now, I had originally said, let me get some space here before I made all this, that we were on this main path of execution. First do this instruction, then this one, then do this, then do this. And we saw a need for a subprogram we could call on over and over again. Well, let's illustrate again why it might be super valuable. What if we have to do this for another set of names? Let's say that now we're going to make first name equal Jane, and we're going to make last name equal to Doe. And then we're going to repeat the same darn thing. Console.log. Now we're just repeating this over and over and over again. Has anybody heard this concept about programming called DRY, D-R-Y? And if so, can they put in the chat what DRY stands for in programming? Don't repeat yourself. That's exactly right. Don't repeat yourself. Good. So some people I know take this to extremes, but this sort of a general concept of if you have to do something more than twice, just find a way to make it repeatable, right? So this is what subprograms were all about. And there was a very real need for them, especially when you were programming in machine language decades ago. And if you were trying to make this the same 50 steps that, instructions that you had to repeat over and over again, if you made a single error in one of them, you were in trouble. Also, if you changed the way you wanted to do them, you had to change it everywhere, every single place it was being used. It was a nightmare. So this idea of a subprogram came into being very early on in the computer industry. Well, that's what all these functions are. So now that we have a main path of execution that goes on for some length, we can start to see the value of, okay, at a certain point, I'm going to want to kick control of the path of execution over to a function that will do this ugly thing for me over and over again. So let's take this function and we'll pull it up towards the top. We'll say, hey, all right, good. So this is my sub program. And of course, we call it a function in JavaScript. Okay, now we'll talk about the different syntaxes for it. They have this thing called arrow syntax on how to make functions that can get things way confused. That's why I find it so helpful to know the fundamentals. And the fundamentals are that this function thing is just a subprogram where you're going to pass control of the main path of execution over to a separate little repeatable chunk of code. Sometimes that code will return things. Sometimes it won't. Sometimes it needs information to do its job. Sometimes it doesn't. Regardless, the concept is always the same. Make a repeatable chunk of code, and when you need to, call on it. So let's call on it. Let's start going here, and just when we do this console.log, let's call on make display name, and we'll pass in first name and last name. And then same thing, we'll do it down here. And instead of this thing that's really long, string manipulation, we'll make that same call to make display name. And we'll pass in first name and last name, the values of which have changed to Jane and Doe. Now, I'm going to look at the chat for a second. Has anybody got any questions so far? Because I'm going to add some weirdnesses into this. All right, so here's my question. Why is it that what I'm passing in right here is a parameter called first name, but what's being received by this function, the parameter, I called it F name. Did I mess up? Is that wrong somehow? Why is that okay? Anybody got any thoughts they want to put in chat? Scope inside the function. Bosconia 3068, you're exactly right. Now, I did this on purpose. Part of the reason I did it is when you're doing a lot of these tutorials, you're learning JavaScript in various ways, quite commonly, the person that made it will match the name of the data that you're passing in, and they'll match it to the parameter name of the function. And then it has to be changed inside. It has to be changed inside. They'll write it like this. This happens often when you see written tutorials. And it confuses the issue because it doesn't separate out the different computer science concepts underneath the hood. The fact is that on line 10, when you see this variable right here of first name, it is absolutely not the same object as this. Now, what do I mean by object? Well, let's get nerdy again. When we're running a computer program and we have all these things up above here, these ones called variables, they are literally being like held in space. This is a euphemism, right? They're an analogy. They're being held in space inside your computer's brain. More precisely, your computer's got a bunch of memory that it's using actively, and it blocks off a tiny chunk of it and gives that part a name and a value. Right next to it, or 1,000 miles away in memory, could be another little object. It's got a name and a value. The fact that they have the same name means nothing. They are separate objects. And that is super important to remember. How do you know which one you're talking about? Well, it's the scope. It's just scope. That's what was referred to here. What does scope mean? It means where does something apply? Where does it live? What does it belong to? From the point we said the word function, any names that we use for things belong only to that function, to how it's declared and what is inside it. That's its scope. So I did it the other way around just to illustrate that fact. And let me do a little bit of Control Z action here and go back to the way it was. And let's look at line 26. On line 26, I'm making my first call to this make display function, and I'm passing in first name. Because I'm calling on make display function, the computer's CPU actually jumps right into this code and starts running it, and is pulling in these two variables. Well, the fact that it's called first name here, and the fact it's called F name here, they're two separate objects. They can have whatever name they want. I can call this one right here foo, this one bar, and I can literally make this return be foo plus a space and plus bar, and the whole thing works. Now it looks weird. It's really bad code readability. But when you're learning a new language, it's sometimes helpful to take the code sample you see in the tutorial somewhere and just muck around with it and try to change the name of a variable or two. If it works, your understanding is pretty good. If not, step back and go, wait a minute. What's the scope of what I'm talking about? If I have a variable that's being made, what's it being called when I send it to a function versus what is it called when it arrives to that function? Is it correct to say that parameters equal a variable? Not really. A variable is a very wide open term. A variable is essentially any sort of named storage location in memory that you're going to use for information that can change as your computer program does its job. It's very generic and wide open. A variable is a broad descriptor. Okay. Parameter is a lot more precise. Parameter says, hey, you know this whole subprogram thing that we've been talking about all night? If I'm going to define or describe this subprogram, and part of my description of it includes information that it might need, those are parameters. So we're getting a little more precise. Now, terminology is actually super important. And by the way, I want to point out and commend someone in the chat who put a little more nuance into it. It's row 6. Says Digital Fortress is how I memorized it, like arguments versus parameters. P parameter equals placeholder. Argument equals actual value. So P for placeholder, A for actual value. That's brilliant. Because here's the other part that gets really confusing. If you're trying to read through this code and you see lines 9 through 12, you might think that when the computer sees this, it's going to run this code. Absolutely not. It's not going to run this code. This is a description of behavior that you might want to call on later. You don't have to. You could literally have the entire rest of the program just do its job and never, ever call on this behavior or this subprogram. All you're looking at here, and this is true of whatever language, so you gotta, that's why I said when you take these 5 things, figure out how the language you're learning implements them, because they all do it in different ways. But for almost every single one, there's a huge difference between describing a potential behavior, a potential subprogram, and actually asking that that subprogram be run. When you're describing it, this is called declaring the function, right? When you're creating the function, then this is a placeholder for the actual data. It's not the actual data because this isn't running yet. So you could call that a parameter. But down here, when we actually call upon this subprogram, or JavaScript name is a function, when we're actually calling on it, whatever we pass in, whatever values, those are arguments to be used by the function that's actually now running finally. We declared it all the way up here, and on the first instruction, we didn't make use of it. Second one, we didn't make. Third one, we didn't make. Fourth one, we didn't make use of this at all. It's sitting out here as unused potential behavior. And finally, we go, oh yeah, that thing. This is where I need it. We call the function. We pass in arguments. That's the terminology. You are passing into the function the arguments it needs. There's a bunch of nerdy math terminology underneath that word argument. Not a math nerd. I'm not going to get into it. But that's exactly right. That's the right terminology, right? So we're passing in the actual value. And when you know that that's what's occurring, this thing about, well, what did they name the variables starts to be a little easier to sort out. Up here, foo and bar are parameters for a function that's just been described or declared, but has not yet been used. So P for placeholder. It's a parameter. It's a placeholder for actual data when we get to the real live thing. Later on, anytime this function actually gets called, what the values that get passed in, we call those arguments. Thank you so much, Stream, for clearing that. That was excellent. All right, good. Bye, Nexus Artemis. Thank you. All right, cool. So this is, of course, a very, very simple function. I'm not trying to illustrate the complexity. The fact is, this is in fact a sub-program, and anything you can do in the outside main path of execution, you can do it inside here. And now it's a repeatable chunk of code. I will say that if the fundamentals of what we just described over the last 30 or 40 minutes, if you have those solid, you can, even though it can be a real pain sometimes, analyze most JavaScript code that you get. It might be painstaking at first, but if you fall back on these fundamentals, you do well. First of all, find out for the code you're looking at, where do we start? What is the actual first instruction that'll be performed? This line 9 through 12 is not it. That's not an instruction to be performed. It's a description of instructions that could be performed later if we ask. So search down through the code and find the first thing that will actually be done. Now this tells you, one, how to read through the code manually with your eyes and scan through, but most importantly, it tells you where to put a breakpoint. If you've got any kind of a developer tool, where to put the breakpoint and watch this thing work. Let's do that in action here. Let's do a little bit of a refresh here and kind of see what's going on, okay? Oh, good, so I'm seeing the behavior I expect. But let's go here to sources. Let's go into our actual JavaScript code, and let's search through here and go, okay, where's the first point I could put a breakpoint? This is a function declaration. Notice, by the way, watch this. I'm going to click on line 9. I want the thing to stop at line 9. It won't even let me because line 9 is not an executable thing. It tries to jump inside the function. So where is it? It's right here. Let's put a breakpoint right here. That's the first instruction. So if I hit a refresh here and start to fetch the files and run the program all over again, I stop right there. So I'm in the main path of execution. So if I click the next call, and notice that's what it says. I'm going to roll over it. Step over next function call. All right. If there's a function call, I'm going to step over it. Click. Okay. There's no function call here, so I'm just going to do this thing and keep going. By the way, let's look at our console. Oh, look, it's working. Okay. Let's go back. Let's do the next one. Now, I'm not sure how much familiarity there is in the class with these developer tools in whatever language you're using, but I want to show you something really cool that hopefully will be even more understandable now that we've covered the main path of execution and subprograms. Look at these little controls here. This one says just continue. From where you are, go forward. This says step over the next function call. Now, what's the next function call? Well, this is make display name. So I'm not going to dive into it. I'm just going to step over it. I should go right here to line 29. Let's hit that. And I go to line 29. Let's continue it and come back around again. I want to show you a different way it could go. Hit refresh. I'm running the program again. I stop at the very first entrance point, right? I'm going to continue on, continue on, continue on. Now, look at when I roll the silver, it says step into next function call. If I click that, look where I am. I've jumped down. Control of the program has transferred away from the main path of execution and is down inside this function. Finally, after declaring the function a while ago, we finally called upon it. And now the central processing unit in performing instructions is no longer out here in the main path of execution performing instructions. It's jumped over here and it says, oh, what do? Oh, I take in are these called arguments or parameters right now? Put it in chat. I'm rolling over the word foo with a value of Eric. Are those called arguments or parameters right now as we're looking at it? Hallway Goal says parameters. That's incorrect. It's a parameter when we're declaring the function and describing its behavior should it be called upon. But now that we're actually calling upon it, because we were on line 26, we called upon it. We passed in these values. That value that comes in is now called an argument. It's an argument for the make display function to be used when it's actually running, when the function's actually running. So here's the argument. Okay. Now, that's a bit of a nerdy distinction that you don't need to get in a firefight about. I only clarified it because when you're reading through someone's code and they use identical names for what gets passed in as what's outside of it, it can get confusing. For you to separate out the fact that they're, never mind the names of it, parameter, argument, whatever, never mind the fact that they might have these odd names, to know mentally that they are two separate things is super important. To know that when you're describing the function as what it will do when it's called on, that whatever you put inside these parentheses is a different thing altogether. It's saying, listen, if I ever do get called upon, here I am, I'm Mr. Function, I'm Mr. Make Display Name. If I ever do get called on, the values that you pass into me, I'm going to call them foo and bar. I don't care what you call them. I'm going to call them foo and bar. Thanks. Now, here I am. Call on me if you need me. And then you look through, and when look through where the computer program is actually running real instructions, performing things, and you look down for when we actually do call upon that function. Now we're in a whole different ballgame. Now you're passing in values, and you get them from whatever variables are outside of the function. You're passing in values, and you're saying, hey, you over there, Mr. Function, I'm ready for you to do your work. Here's a value. I happen to be calling it first name. I don't care what you call it, just do your job. And it says, oh, good. Here's that value, Eric. I'm going to call that foo. Here's that value, bar. I'm going to call that gross. Well, no, sorry. Here's that value, gross. I'm going to call that bar. And it says, okay, let me do my job. All right, so I'll take the value of whatever I'm calling foo. I'll take the value of whatever I'm calling bar. I'm going to concatenate them, stick them together with a space, and then I'm going to spit that back out and return it. Again, doesn't matter whether you know the terminology or not, okay? So let me repeat the difference here, okay? At the time of designing the function, declaring it, whatever's inside these parentheses, we call them parameters. At the time of actually calling upon that function to run, whatever values you pass into it are called arguments. I'm clarifying that again because I saw that requested in the chat, okay? So you can call at design time when you're declaring the function, you can call it P placeholder parameter, right? P is for placeholder. It's a placeholder for what will actually get used when you actually are using the function, when you're actually calling on it. All right, good. But back to what we have, because right in front of us, we have a live computer program and we've stopped it cold. Why? Because we started running instructions here at line 16. We ran line 18, we ran line 20, and then 22, and we got to this one. And we said, instead of just jumping over the fact that we're calling a function, instead of jumping over, we used this little control here, and we stepped into the function call. And so now we're inside the function call. Well, now we use the same like step over function here, and it'll go to line 11. You can even roll over this and go, oh, look what it is. It's Eric Gross with a space in between the words. And it'll say return. Now, this keyword return should now make even more sense to you. It isn't that we're returning to the main path of execution. What it means more precisely is, hey, now listen to this very carefully. It's not that we're returning control of the program to the main path of execution. Rather, it's that the main path of execution called upon this function to be done, and we are giving back to the main path of execution a thing. The thing we're giving back is this display name string, and the way we give it back is by using a keyword called return. And by the way, that word return is very common across tons of computer programming languages, and it almost always means the exact same concept. Another section of code, in this case, the path of execution here, the main path, I called upon this function to be performed, and I expected it'll give me back something. So the function, when it's going to give back that thing, uses an instruction called return. Well, we're just about to do this, and we should jump back into the main path of execution. What's the next instruction that will be performed? What line number is it on? After I'm done, and I continue on here, which I'm going to do in a second, what instruction line should be performed next? I'm looking at the chat. Line 29. That's exactly right, Wosex. Let me refill my water. I'll be right back. It's right next to me. It's exactly right. Because this is, before we do it, let's just think through here. We started with our very first instruction. We went consecutively all the way through them till we hit this one where we're going to call another subprogram. We've called the subprogram and we're running the little teeny code inside it. This is a little mini program. Lines 10 and 11 are like a mini program. We're done. There's no more instructions. Once we're done with line 11 here, we're done with whatever this thing can do. So we go back to where we left off in the main path of execution. We left off on line 26. Let's click this. Okay. Now, there's a tiny little nuance. This is actually worth discussing. The fact is, we weren't done with the log part. We had done the make display, but make display was only doing its job so that the log function, because log is a function like anything else, we were only using make display name function to produce the content that the log function will work. So the log function is actually where we were when we jumped into make display name. Now, it's a tiny nuance because we don't mess around with like what's inside log very much, but it's true. So now when I hit continue again, now I go to 29. Awesome. Okay. So when Woe6 said 29 and I agreed with him, I was technically wrong because of that little nuance. For the parts that I care about in terms of analyzing my own code, I know the next thing I care about running would be line 29. There is, of course, this little log that had to be done, which is great. I'm glad to be wrong about that because it opens up some nuance. All right, so here I am. I'm back in the main path of execution, and I'm going to continue on until I'm directed elsewhere. Let's see, I did that. I made first name equal to Jane now. Last name should still be Gross. It is. Well, I'm going to log Jane, and then I'm going to change the value of last name. Did all that. I'm still in the main path of execution, one step after another. And I did that. And if we look over at the console.log, well, they're all logging, right? But now I'm going to call upon this function again. Now, let's reinforce the terminology. I'm passing in values to this function when I call it. We call them arguments. So I'm passing in as an argument the value, the current value of the variable first name and the current value of the variable last name. When they come into the function call, and we'll be there in just a second, inside the scope of this function call, we call the values we're using by these names. And we call these arguments. We have an argument here called foo. We have an argument called bar. Why arguments? Because arguments are for when you're actually running the function. Again, it's not super important a nuance. But now let's do this. How do we jump into it? If I just click this button right here, it says when I roll over it, step over the next function call, it'll just go past it and it'll exit. We're done running our code. I want to jump inside it again. So I use this right here, step into. Let me do that. Okay. Now, another thing to know. Shouldn't be a surprise to anybody that we dove down inside this function call. But notice what this fourth button over here is. Step out of current function. Maybe down here after line 10, maybe this is a huge function. Maybe there's another 50 lines to be run. And I don't want to go through every single one of them one step at a time before I return to the main path of execution. I can click this and it'll pop out of the function you're in and jump back where you were before. So that's what this does. Okay, gone on for quite a bit, 90 minutes, right? And it was, I would say, quote unquote, it's all about functions. But I'm just trying to reinforce these 5 fundamental aspects of any computer program and how they apply in JavaScript. And to illustrate that if you think about, well, what's the path of execution I'm on right now? And anytime you see a function call, realize that you're transferring the execution control over to another chunk of code. And when it's done, only then will you come back to where you were and you'll pick up where you left off. And then when you do that, when you call upon this sub-program concept, sometimes you have to give it information, you have to give it arguments, sometimes you don't. Sometimes it gives you information back, sometimes it doesn't. It totally depends on what's the repeatable thing that you need done. The function is the quote unquote repeatable thing, and the what you need it to do is the little teeny mini program inside. Any questions? Oh, on the top right part of the screen, Koana, I'm so sorry. Let me see if I can make that a little bit easier to see, because it's really important to understand these little buttons. I will collapse this a little bit. I'll pull it over. And now it should be in the center. Koana, can you see that a little more easily? All right, let's repeat that again so you can see the difference between these 4 buttons. I'm just gonna, this button, by the way, resume script execution. Awesome, thanks, Koana. I'm gonna run it and just be done. Now let's start all over again. So when I hit the refresh button over here on top left, reload, right? It's gonna start our program over again. I'll click that. Again, we're in the main path of execution. We've hit the first instruction. This one right here says step over the next function call. Well, we're not even doing a function call. Line 16 doesn't call a function. The effect of clicking on this is just to go to the next instruction. So I'm going to click on it. Click. Now go to the next one. Now, this is in fact a function call. We're calling the function log. And we're passing in an argument of whatever the value of first name is. Now, I've never actually done this, or I have, it's been years. I don't know if I can step into the log function. Let's try and see if it'll let me in. Because, and now this is the part that Koana wasn't able to see as easily. This next button to the right, these are your debug buttons, okay? Says to step into the next function call. Well, we're about to call the function called log. It's built into the JavaScript language. I don't know if it'll let me in. Let's click. Nope, it won't let you in. That's true with a lot of these built-in JavaScript functions. Fine, we'll use that button on our own function in a minute. Anyway, we're still inside the main path of execution. So I'm still, if I want to go forward, clicking on this button right here, F10, in almost all integrated development environments or all developer tools, F5 lets you continue. Well, they use F8 here. Yeah. F10 is this step over the next function call in a lot of developer tools. So let's step over it again. Again, we're still in the main path of execution. Step on it again. Now we're about to go outside of the main path execution. We're going to go into the subprogram. That's where this button comes in. Step into the next function call. I want to step into the make display name. So if I click on that, now I am in fact up in here inside it. And the last one I wanted to illustrate to you, to everyone, but Koana, take a look at this. It's the one on the right here that says step out of the current function. Now I'm inside here. I'm going to put a breakpoint on line 11, but I shouldn't hit it. Haven't done this in a while, but if I click on this, it should bypass the breakpoint on line 11. It won't stop there. It's just going to jump out of the current function. Didn't do it. All right. That's because I put the breakpoint. If I had a super long function, that would be really valuable because I would jump back into where I am. So those are those 4 control buttons. Just continue, step over the next function call. If there isn't a function call, it just goes to the next instruction. Step into the next function call. And if you're inside one, just step out of it without, maintaining that step, one step at a time. Does that make sense now, Kawana? Good. Okay, good, excellent. All right, so that's a bunch of stuff on functions. Now, I want to point out that we're doing this learning about JavaScript up in the browser only because, not because this is browser related stuff. I'm doing nothing related to web pages here. We're dealing with rock dead, stupid, simple JavaScript fundamentals. I just need a place to run some JavaScript code. That's all. There's another place to run JavaScript code, but you have to use a special tool. Can anybody put in chat what the tool is that can be used to run JavaScript if you're not going to use a browser? Node. Wo6, you're spot on. So before I get into asking like what exactly is Node, I want to point something out. I used a couple of words much earlier in the class tonight called a JavaScript engine. Chrome has a JavaScript engine, a continually running program that you can feed JavaScript code into. I'm highlighting some JavaScript code. You can feed the JavaScript code into it, and it will in turn create machine language and give it to your computer, and your computer will run it. That's what's happening. Every single time I step through one of these things, the fact that the CPU can do any work is only because something turned my JavaScript into machine language. That's called the JavaScript engine. But those, for years, those JavaScript engines, they were only available in browsers. But then about 2009, a really cool thing came out. It's called Node. It's an engine that you can run just on your computer, on any computer really, with a modern operating system. And that program called Node will act as an engine. It'll take in JavaScript and it'll turn it into machine language. You don't need the browser. Well, that's really cool. So that's what Node is all about. Okay, good. A couple people got that. Excellent. All right, good. So that's a subject for another class, is Node and how it works. But I want to point out that even when you look at the complexities of that other whole system of Node, the fundamentals of JavaScript still apply. They still apply because it's the exact same language. Yes, when you're operating it in the browser, there's some special things available that are totally related to the browser. For example, JavaScript's got a bunch of built-in functions that let you reach inside one of these web pages and grab a hold of different divs in it. Here's a div. And you could, because it has a specific ID, there's special functions inside of JavaScript that can grab a hold of that div and change the content in it. Well, that's not going to apply when you're not running JavaScript in the browser. So in Node, that wouldn't be much of a thing. But that's not part of the core aspect of JavaScript. It's just one more built-in function. So all the same concepts we've been covering here should apply. All right. I think that's probably about it. I was planning on between an hour and a half, 2 hours. We've got about an hour and a half. I see a few viewers have dropped off. I want to tell you, by the way, how much I sincerely appreciate the involvement. Some very particular things about it. Really intelligent, good questions, suggestions, and help in the chat. It's not a very wordy, verbose chat with a bunch of stuff going on. It's related to what we're talking about. And when I needed help, you guys gave it, which is really, really cool. Right. So thank you all for checking in or for tuning into it. I'll be doing another one of these on Monday at 8 p.m. Pacific instead of 7. I'm doing it 8 p.m. Pacific. And that one, we'll do some more fundamentals of JavaScript, but we'll switch over to Node for that one. So we'll be writing our code in a different sort of environment. We don't have to run it inside the browser. Okay. Absolutely, Kawana. I'm really, really glad to clarify that. Main program and subprogram just pulls things apart inside your mind, hopefully. That helped me so much when I understood that. Absolutely, Holly Goal. I'm super glad to be here. Anyway, we'll sign off for the day. If you want to follow me, just all my go to Twitter. Also, if you look my links for on Twitch, it has all my links for all my other socials, and I'll be glad to see you. Otherwise, this thing wouldn't have been a success if you guys hadn't shown up. So thank you. I super appreciate it. It's the first time I've ever done this and you guys made it really, really enjoyable. Have a great night, everyone.